Okay, here we're going to do some more definite integrals with u-substitution, and first one we're going to look at is number 3 that I gave you, which is the integral of secant 2x tangent 2x dx from 0 to pi over 6. And again, this is something that we have to do u-substitution for because we don't have a formula for secant 2x tangent 2x. We have one for secant tangent, right? So obviously then we want u to equal whatever's inside here. We want u to equal 2x. And that means that du is going to equal 2 dx. Take the derivative. Okay, so let's rearrange this to make sure everything's going to fit nicely. So we got the integral from 0 to pi over 6 of secant 2x tangent 2x. Then we need to have a 2 dx. That's going to become our du. And if we're multiplying here by 2, that means we've got to multiply outside here by a half. And now we can start to do our u substitution. So the 2x is going to become u. So we've got secant u, tangent u. 2 dx is going to become du. We still have the 1/2 out here. That's just a constant. But big thing is remembering to change these bounds. So this 0, the 0 that was here, we've got to plug it in here for x. That's going to give us 2 times 0. Well, that's still 0. Boom. All right. But this pi over 6 right here, that is going to get plugged in here. And that's going to give us 2 times pi over 6, which is going to give us pi over 3. So now our new upper bound is going to be pi over 3. Okay, so now we can integrate this secant u tangent u du. And the integral of that is going to be secant u. We want to evaluate that from 0 to pi over 3. We're going to multiply that by a half. And we get, well, pi over 3. We're going to have to use our special triangle again. So draw a triangle. Or you have these memorized, unit circle. So this is pi over 6. This is pi over 3. This would be 2. This would be 1. This would be square root of 3. We're talking about pi over 3. Secant is the inverse or the reciprocal of cosine. Cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. Over adjacent. And for pi over 3, we are looking at this angle right here. The hypotenuse is going to be 2. And the adjacent angle, the adjacent side is 1. So secant of pi over 3 is just going to be 2. Minus, then we put in 0. Well, if we're at 0, cosine of 0 is 1. So the reciprocal of that would also be 1. So remember, we evaluate this, we plug this in, minus, so we're taking secant of pi over 3 minus secant of 0. So that's 2 minus 1. And then lastly, we would have to multiply that by a half because we got this half on the outside here. So that is going to give us just our answer of 1/2. Okay. Try to do one more here. We've got the integral. This is number 4. Got the integral of from 1 to 3 of x over x squared plus 1 dx. And here we would let u equal x squared plus 1. Why not? It's what? It's on the bottom here. It's something we can integrate easily. And when we do integrate that, we get a nice 2x dx. And we just have to make sure that we can fit that in. So we already have the x, we just need the 2. So we can rewrite this. We can put the 2x on the top over x squared plus 1. Now, since we put that 2 up top, we have to multiply the outside by 1/2. And we have our integral going from 1 to 3 dx. But now we do the u substitution. So the u substitution gives us just 1 over u du, because the 2x is our du, and the x squared plus 1, well, that's u. And we still have the 1/2 out here, but we need to remember to change our bounds. So this 1 is going to get plugged into here. So look at that number. Plug it into here, square it, add 1 to it. That's going to give us 2. And the next number, 3, that's our upper bound. We're going to plug it into here for x. So we're going to have 3 squared plus 1. And what is that going to give us? That's going to give us 10. So we get 10 on the top. Now, what is the integral of 1 over u? The integral of 1 over u is the natural log of u, actually natural log of the absolute value of u. And we're going to evaluate that from 10 to 2, and then take 1/2 of that. So what does that give us? Well, since we're putting positive numbers in here, we don't really need to worry about the absolute value. So we're going to have 1/2 of the natural log of 10 minus the natural log of 2. Now, there is this little property of logs. So property that says that the log of u minus the log of v is equal to the log of u over v. So that is a property of logs. So one thing we can do to simplify this is to make it just 1/2 natural log of 10 divided by 2, which is going to be 5. So we have 1/2 natural log of 5. And that'll be it for this video. I like putting 1 or 2 problems together. So stay tuned for the next